Identify the center vertices and co-vertices of this guy here. All right, well, first things first, it's not a parabola. It's not a circle. Why isn't it a circle? Because there's a number in front of y squared and not a number in front of x squared. So is this an ellipse? Yes. Why? Because both of these are positive. If one of these were negative, then it's something else. You'll find out in the near future of what that something else could be. Now, when I did a problem like this with a circle, the thing that I did first is I grouped everything up by variable, and then I ended up completing the squared, and I'm going to do the same exact thing here. So I'm grouping the x's, leaving some space, grouping the y's, leaving some space, and that's going to, while I'm at it, by the way, let's subtract 225. There you go. Okay. Before I go any further, before I tarry further, let's do this. In order for me to do completing the square, I really want nothing in front of y squared. So let's rewrite this out, and let's factor out a 9 so we can, for the moment, pretend that there's nothing in front of y squared. So this becomes negative 10y, leave some space, set that equal to negative 225. Okay, the part here in purple, not so bad. I'm going to add 9. Y, half of 6 is 3. 3 squared is 9. Got to do the same thing over here. I'm going to take half of negative 10, which is negative 5, square that and make it 25. Now this is where you have to be careful. I'm not going to add 25 to both sides. Technically on the left here, 25 lives inside of a parentheses that's being multiplied to 9. So if I'm going to add something to both sides, I'm adding 9 groups of 25, which is 225. Okay, tricky. Tricky. But what that leaves me with is x plus 3 squared plus 9 parentheses y minus 5 squared equals 9. Now, if it's an ellipse, I have to make this equal to 1. So let's divide everything by 9. And ooh, God is good. Look at that. Over 9. And my standard form is now coming together. X plus 3 squared over 9 plus y minus 5 squared. I'll put over 1 even though it's not necessary, is going to equal 1. Now, for an ellipse where the number underneath the x is bigger than the number underneath the y, I have this form right here that I'm going to write up. It's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. My center is going to be hk. So if negative h is equal to negative 3, then h is going to equal positive 3. And if negative k is equal to negative 5, negative h is equal to positive 3, so h is negative 3. That changes a whole lot if I don't do that. Negative k is equal to negative 5, which means k is 5. There's my center. My vertices are given to me by the formula h plus or minus a k. A is the square root of 9, which is 3. So my vertices are going to be h plus 3 or negative 3 plus 3. K doesn't change. And my other vertex is going to be h minus 3 or negative 3 minus 3, which is negative 6, 5. Those are my vertices. My co-vertices are given by the formula h, k plus or minus b. We already know what h and k are. B is going to be the square root of 1, which is 1. So my vertices are going to be h which is, negative 3. My k is 5, so 5 plus 1 is 6. And negative 3, 5 minus 1 is 4. Not graphing this one, kind of ran out of space. But if we had to graph it, we'd be able to, and you can watch a video on how to do so if you're dying to know.